This is guided practice 13 for 7.4, and this is problem number 2. Note that we have a 1 divided by a fraction with a polynomial on the bottom, and if we try to u sub for that, there is nothing on the top to compensate, so we're going to have to go partial fractions here. So my first approach is to factor my denominator. So if we take out that x, I can see that I then have a remaining perfect square trinomial that I can factor as x plus 1 squared. Okay, now when we expand this, I get an x on the bottom, and x plus 1 on the bottom. Sorry. And an x plus 1 squared on the bottom. And each of those gets a constant, right? Even the square, which would normally get an ax plus b, gets just a constant here because it is a repeat, right? It is a linear repeat. So I need both linear repeats, the original and the square. From here, I want that, which is a over x plus b over x plus 1 and c over x plus 1 squared to be equal to the original, which is 1 over x times x plus 1 squared. If we multiply by that denominator, x times x plus 1 squared on both sides, what happens is the following. The x cancels and I get a times x plus 1 squared. The x plus 1 will cancel and I get b times x plus 1. And I will have c times x equals 1. Okay. Now, if I try plugging in numbers, I can get some of these values. So, for example, I can get, if you let x equals 0, that means my b and c term go away. And I have that a equals 1. So I can get that one. Great. If I let a equal negative 1, then the a term goes away, the b term goes away, and I get negative c equals 1 or c equals negative 1. And then I just have to do some work to get b. And so what we can do here is let's plug in our 1 and our negative 1 and see what happens. So that gives me x plus 1 squared plus bx squared plus bx minus x equals 1. And I'm going to keep the b's on the left. So bx squared plus bx equals x plus 1 minus x plus 1 squared. Okay. All right. Now what? Again, this has to work for any number. So if I plug in 1 here, that's, if I let x equal positive 1, that's going to give me b plus b equals 2 minus 2 squared. And that's going to be 2b equals 2 minus 4. 2 minus 4 is negative 2. Divide by 2, and that gives me b equals negative 1. Okay, so that's just one way to go about it. The other option is to do what we did in number 1, which is just to multiply everything out and equate coefficients. So that's always an option. But in this case, I get a equals 1, b equals negative 1, and c equals negative 1. Let's bring that back over here. So that means that I'm trying to find the integral of 1 over x minus 1 over x plus 1 minus 1 over x plus 1 squared dx. The first one is just going to be ln x, not a problem there. But the second and third, I have the x plus 1 in the denominator, so I'm going to u sub for that twice. It'll be the same u sub for both pieces. And this is going to give me the natural log of absolute value of x minus the integral of 1 over u du minus the integral of 1 over u squared du. This becomes the natural log absolute value of x minus natural log absolute value of u plus 1 over u plus a constant. And then we plug our u back in. So this is x plus 1 plus 1 over x plus 1 plus a constant. And that's our answer to problem number 2.